Hi everyone, this is Professor Mayunger and you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started.
Hello viewers, this is our 19th exercise and we will be modeling this one using Autodesk Fusion 360. You can see three different views are available. This is the top view, this is sectional view, and this is the isometric one. So it is better to start from the top view itself. Initially we need to make a set of concentric circles of a different diameter, and we need to provide one arc which will be tangent to both the circles here and here. And based on requirement, we need to extrude different areas with a different depth, right? So without wasting time, let us start our modeling using Autodesk Fusion 360. First of all, we need to create a new design, and we can save it by the name of exercise 19, and we are saving this one to a specific folder by the name of Fusion. Let us save this one. You can see exercise 19 is saved, right? So initiating sketch from here, and as told before, we are starting the sketch from top plane, right? Initially we'll do a different set of concentric circles at random, and later on we'll provide exact dimensions. So I've made 4 set of circles. These are concentric. Again, here at a specific distance away, we'll make 2 concentric circles. And next to that, we can provide one construction line to consider this one as symmetric object. So starting with construction line, and change the line type from solid to construction. Let us join this one. Right. Now you can see the drawing to understand the model in a better way, in which you can provide exact dimensions, right? So you can see we are having different dimensions or different diameters. Inside we are having two diameters of 20 and 38 millimeter. This one will be having diameter 38 and this one will be having diameter 20. So we provided two concentric circles of diameter 20 and 38. Next to that, we need to see the other circles here. In this case, we are having different diameters of 64, 55, 43 and 34. So the external one is having diameter 64, next one is 55. So this one will be 64, next one will be 55 millimeter, this one will be 43 millimeter diameter, and last one will be 34 millimeter diameter. We provided all set of concentric circles with different diameters. Let us see the drawing again. And the distance between them is 75 millimeter. And in this case, we need to provide an arc which will be tangent to both the exterior circles, which will be having radius of 64 millimeter, right? So the distance between them is 75 millimeter. We can select the distance. This will be 75 millimeter. Done. Now we need to provide an arc which will be tangent to both the external circles, right? We need to change the line type from construction to solid one. Then we can create arc. It will be 3-point arc. Let us start from here at any arbitrary location. We're making any arc. Now with the relation, we can make it tangent to both the circles, right? So starting with tangency relation, this circle and this arc will be tangent, and this is already tangent, right? Now we need to provide smart dimension to this one. It is having radius of 64 millimeter. So smart dimension will be 64 millimeter. Done. It is black completely, so all the dimensions are fully defined. Now we need to make a mirror of this one. So create mirror. Let us select the specific line, and next to that we need to select the mirror line. This is mirror line. Done. Okay, our drawing is completely defined, so we can finish sketch, and that will be extruded to a specific depth, right? Actually, at a defined locations, we need to have defined extrusion depth. Let us see the drawing again to see how much is the extrusion needed at different locations. You can see at the middle position, we need to have an extrusion of 10 millimeter, and outside will be 30 millimeter, and here in this case we need to have extrusion depth of actually 45 millimeter. So initially we'll make the middle position to be extruded to a depth of 10 millimeter. So extrude we need to select the specific area. From direction, we need to select symmetric, and while selecting measurement, we can select the whole length to be extruded to a depth of 10 millimeter. Okay, done. You can see this is the extruded part, right? Now to see the remaining part, you can see the object from here. This is hidden, we can make it clearly visible. Now we need to select define locations for different extrusion depth. Let us see the drawing again. We need to extrude this part and this part by 30 millimeter. So starting with extrude, let us select a specific areas, and from direction we can select symmetric, and that needs to be extruded by whole length to a depth of 30 millimeter. We are joining this one to the parent body. Done. Right, two areas are remaining. At two different areas we need to provide different depth of extrusion, right? Let us select the drawing again. This part is having different depth of extrusion. At the top part it will be having extrusion depth of 10 millimeter, and down it will be having extrusion depth of 15 millimeter, because this is 5 millimeter. Here in this case, at this location it is not extruded symmetrically. You can see the original drawing again. Some cut is here at a depth of 5 millimeter, so it is extruded total depth of 25 millimeter. It's not symmetric. Down it is extruded by a depth of 15 millimeter, and up it is by 10 millimeter. So total depth of extrusion is 25 millimeter, right? So starting with extrude, let us select a specific areas, and it will be extruded in both directions. We need to extrude different depths at up and down. So from direction we can select two sides, up and down. You can select up, it will be extruded by a depth of 10 millimeter, and down it will be extruded by a depth of 15 millimeter. You can make this one as a new body because we want to show this one as a different entity, so we're creating this one as a new body. If you want to make this one join with the plain body, then you could have joined this, but here in this case we're creating this one as a new body. Okay, done. So this is a separate entity, right? Now the innermost position is remaining. Let us see that one must be extruded. The innermost position to be extruded by a depth of 45 millimeter. Downside it will be extruded by a depth of 15 millimeter, and up it will be extruded by a depth of 30 millimeter. Again we need to proceed similar way. So starting with extrude, let us select a specific areas, and let us select two sides. Let us select downside to be extruded by a depth of 15 millimeter, and upside to be extruded by a depth of 30 millimeter. Done. And again we are making this one as a single entity or different body. Okay, done. Now we can hide this sketch. This is our object. Here we have three different bodies actually inside, right? So we can color accordingly, can provide different appearance to this material, right? So for appearance, let hit A, and we are providing metallic appearance to this one. Let's consider this one to be stainless steel satin. Okay, and this inner part, let us make this one to be made up of polished copper. This intermediate position is made up of polished copper, and we have to make the inside position to be made up of polished titanium. Okay, so this is our body, right? So this was a very simple model, and while modeling this one we have selected a set of concentric circles, and the exterior sides of the circles were joined with an arc which was tangent to both the circles, and it was extruded to a different depths based on requirement, right? So this is all about our 19th exercise. Thank you so much for watching this video. Thank you again. Bye. If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.